Well, welcome this morning, everybody, to the final of the two-part workshops on Gephi. For those of us who joined us last week, or whether you watched on YouTube afterwards, the first workshop gave an overview of the tool and how to use it, and then you all had a little bit of homework to do to prepare for today. And so before we turn it over to Dr. Vanderkolk, who's going to run part two, we'll start with an Indigenous land affirmation. Nous rendons hommage au peuple algonquin, gardien traditionnel de cette terre. Nous reconnaissons le lien sacré de longue date, l'unissant à ces territoires qui demeurent non cédés. Nous rendons également hommage à tous les peuples autochtones qui habitent Ottawa, qu'ils soient de la région ou d'ailleurs au Canada. Nous reconnaissons les gardiens des savoirs traditionnels, jeunes et âgés. Nous honorons aussi leurs courageux dirigeants d'hier, d'aujourd'hui et de demain. We pay respect to the Algonquin people who are the traditional guardians of this land. We acknowledge their long-standing relationship with this territory, which remains unceded. We pay respect to all Indigenous people in this region from all nations across Canada who call Ottawa home. We acknowledge the traditional knowledge keepers, both young and old, and we honor their courageous leaders, past, present, and future. So I won't delay us any further. I'll just say let's turn it over and we'll dive into part two.
Excellent, thank you. So I've got the fancy screen sharing going on, so let's see if it still works. Here we go. So you should be seeing the slides now, if everything works as expected. And that's kind of where we left off last time. So we had some exercises. And the first exercise is basically to go back to the previous slide and just try out everything that we talked about last week. And before I go to like the handling of the solutions of the exercises that come later, any questions about the material that we covered last time?
I think even given this format, if you have a question that's complicated to type, you could raise your hand and we could take a question that way too.
Yeah, for sure. There's not that many of us, so you can just, yeah, anything goes. Okay, so then there's another statistics that I wanted to discuss that we didn't do last time. So this was part of the exercises. This was playing with another statistics called modularity. Modularity is really great for finding communities. So it's an algorithm in Gephi that will automatically find groups of people that kind of naturally fit together. So for Twitter, this could be like groups of people that often talk to each other. And for the data set we have for the Illinois high school kids, it would be the groups of friends that you would be able to discern like that. So let's try that out. I should have Gephi ready to go. Here we go. So I should get that out of the way. Oh. Load the data. So this is the data for the high school kids again. That is totally random. So I'll just do what we did last time, run the force atlas, and then the Vruchtenman Rheingold. And I think we had like this size based on the degree, something like that. Yeah, so under statistics, you would have the modularity. And if you run that, you can accept the default options. Then you get this little report that shows you the different modularity classes. And then you close it, nothing changed, except that you now have a number at modularity, which means that this thing ran. And now we can use the color to partition by modularity class and then apply. And now you get these groups of people that are all very connected. So if we zoom in a bit, and we look at the green group, the light green group, we see that most of these are very interconnected with each other, and there's relatively few connections to the other ones. Actually, this one is kind of funny, the teal color, I guess. It's part of this group, but it doesn't look like it, and that's because of the way it, how it forced the layout. So actually, this is more suitable to be placed there. So it just shows you again how useful it is that you can manually drag these nodes as well. Let's see if I run it again. Yeah, that's a bit better. Actually, these blue ones are also connected to each other, but it doesn't look like that in the picture because of the layout. Let's see. I see a few questions in the chat there. If I've chosen a size ranking, how can I undo that selection so that all nodes become the same size again? Yeah, so if by the ranking, see size, you can choose unique. So if you choose unique and apply, then everything becomes the same size again. And you can manually specify the size. I'll put it back to a degree. Yeah, so that's the modularity. I think I even had a slide for that. So let me just go back to that. Just did that. So yeah, the interpretation of that, that's what I was talking about. So yeah, these are groups of people that like their friend groups within the high school classes. And yeah, this is really great tool for finding these modularities, finding these modularities. So a bit later, we'll get to another example where we look at a review of papers written in a specific topic. And then you can find like the researchers that all work together like with one click. So any questions about these modularity classes? Yeah, I'm not sure if you play with any of the other statistics that you can play out with. I haven't actually tried all of them myself. That you can run and you get graphs. And it's not always entirely clear what they mean, unfortunately. But modularity is a very important one. And average path length that we discussed last time is also an important one. Okay, so then a bit more about the filtering. So last time we talked a bit about filtering. I think we filtered by topology, but you can also filter by attributes. So now that we've run the modularity, we can, let's see, which one is it? Equal modularity class. And if you run that, you can really highlight very specific ones. So this is modularity class 1, 0, 1, 2, etc. So that filter tool lets you really highlight the classes that you want. And if you press stop, and you get the whole picture again. So in this case, it probably doesn't make a lot of sense to filter by a specific class, but if you get like bigger and bigger networks, this will help you a lot. Another really nice filter is inter-edges. So inter-edges and inter-edges, they tell you stuff about how the nodes are connected. So if you take the modularity class for the inter-edges, and I take the modularity class for the intra-edges. So now I have them both here. And I select, let's see, 0 and 2. If I filter here, let me just make the lines a bit thicker so you can see them. So now you have like all the connections between all the people. But if I filter it, you can see you can only get the links between modularity class 2, which is purple, and modularity class 0, which is the green one. And that lets you know how these classes are connected with each other. But if I do the same for inter edges, then you get the connections with themselves. So these intra edges and inter edges filters, it lets you really focus on the connections between these different groups. And another one that I want to show is the operator. This one is actually not in the slides, but it occurred to me later that it's actually very useful that you know about this one. So the operator lets you combine multiple filters. So say you want to visualize both the connections between the groups, the connection between the group members, but also the connections between the groups themselves. So you would like a combination of the intra-edges, so intra-edges and inter-edges. You would like to combine them. And the way you can do that is with a union. So if you go to operator union, you put that in, and then you expand it. Then you get this little thingy that says drag subfilter here. And then we can go back to inter-edges modularity class, put that in there, and also inter-edges modularity class, put that in there. So let's select this one, 0 and 2 again, and the other one, 0 and 2. So now you see that you have both the connections between the members themselves, but also the connections between the two groups individually, so the groups as a whole. Oh. So any questions about the filter or the statistics? I have a question. I did the visualization with the data from the Web of Science. I wonder if it's possible to draw the network of most frequent keywords in a field. I would like to look for the most repeated terms or concepts in my field of study and see how the keywords are connected. Is it possible? It's a good question. Pretty sure it's possible, but on how to get the data out to actually show that, that is a good question. I think Web of Science should be able to do that. So get the data from the abstract, yeah. So how would you approach that? Yeah, you would have to find the keywords for every article and then link them together. I'm not sure if there's an automated way of doing that or if that's something that you have to program yourself and generate a data file and then read that data file into Gephi. Yeah, it's a good question. I'll have to think about that a bit more. Okay, so let's stop the filters and then we can concentrate on the preview. So you always have to click refresh to actually show the whole image. And then we had a few exercises on how to make this image well, prettier. So one of them was the border width. So we could set that to 20 and refresh. And then you get like nice thick borders that actually make the picture look better, in my opinion. It's kind of thick, so we also have the opacity that you could change. So if you change that to 60, then you see that they actually become kind of transparent. So you can actually see the connections inside of them now. The other thing you could do is show labels. That one. Oh, where did it go? Did I forget the labels? There's labels there. Oh, that's weird. Show labels. Oh, sorry, I selected edge labels. There's no labels for the edges. Node labels, that's what I want. There you go. So you can get the nodes label, node labels. And then you can change with the font size, play with the font size. And then it fits nicely in there. Also have the outline size. So if you change that, then you can see that the fonts get like a white board around them. In this case, it doesn't matter much, but if you have a lot of text and it starts to overlap, then having the outline is really useful. Actually, I can show it if I put, oh, I can't do that here. If I go back to the overview and I have this one kind of overlap that one, I go to the preview again. Then you can see if you have a white outline around the text, then it's still very readable, even though there's text right behind it. Like if you remove the outline, then it becomes completely unreadable. So this outline is like a really nice one to have. You can also play with the edges. So let me just put that outline back to 5. Refresh. Yeah, you also can play with the edges. So currently the edges are kind of small and they're curved. So if I set the thickness of the edges to like a lot bigger, it becomes a bit less, what's the word? Less clear, but it does look a lot prettier. So it's kind of, you have to find like the golden value for that. So let's make it a bit smaller. So that kind of looks nice. And the colors are automatic from the modularity classes. But you can change the colors if you want. So currently it's mixed. And that means that if you go from an orange node to a blue node, then you would have a mix of the colors. So to show you what I mean with that is from this blue one to this green one, you can see that it's not the green from green to green or the blue from blue to blue, like it's a mix of colors. And it's the same over here. So this green one goes to this purple one. So the edge in between, it's like a mix of them. So that's what is meant with mixed. You can change it to like source, refresh. And you can see this one now turn purple because it goes from this one to this one. And if I set it to target, then it will turn green, refresh. But mix is like a nice one because it mixes the colors. So you can see that it's a connection between two nodes of different modularity classes. So then there's also the curvedness. Let's see, curved. If you turn it off, then everything becomes straight. And you can also manage the radius yourself. So if you set it to 20, oh, sorry, that was wrong. So the radius lets you set the distance between the center of a node and the start of the edge. So let's compare it again. If I set it to 0, you can see that it goes right to the end of the edge here, but it makes the image kind of crowded. So if you set a radius of 20, it takes a distance of 20 pixels between the node and the start. So that makes your diagram a bit less cluttered. So it becomes like more pleasing to the eye. Maybe 20 is a bit too much, but you can set it to 10. Saves a lot. And then finally, the edge arrows. So that's the size of the arrowheads here. You can change that to like 5. And it will make the arrows a lot bigger. And that's a bit much. Let's take this out. So any more questions about making these pictures prettier? Where can we add labels in the data laboratory? Yeah, okay, that's a good question. So if you go to the data laboratory, you have to click on edges here. So you can choose between nodes and edges. So if you go to edges, you'll have a column called label. This is a label. So I made a connection between 1 and 14. So if I go back to overview, I turn on the edge labels, then you can see it appears there. And that's the one between 1 and 14. So yeah, you have to go to data laboratory, make sure you're at edges, and that's where you can enter the labels. Yep. So then we'll close this project. I will not save it. And now we're going to do the other exercises where we loaded data from CSV files separately. So if you go to the data laboratory and we file open, oops, and then the file that we needed was lbl.csv, which is short for label. Shows you exactly what's importing. And then it asks the question if you wanted to add it to the new workspace or append to an existing workspace. So I want to always choose append to existing workspace. And the screen is now clear, empty because I'm still in edges mode. So if I go to notes, all my notes are there. So I can again choose file, open, and this time choose the connections. So that's, oh, I call it connection instead of con here, but it's the same one. Open, it detects everything again. That's fine. And then again, I need to choose append to existing workspace, because if you do new workspace, it will make a new workspace and it will never be able to link the nodes that you imported earlier to the connections that you're now importing. So now if you choose between nodes and edges, you should have data in both the fields. So the edges here came from the connection.csv file, and the nodes came from the label.csv file. Okay, so if we go to overview, we'll have a graph like this. But we can still go to the data laboratory and we can add ourselves to it. So you can add data to the data that you already read in. So if I click on add node, which is right here, you get to put in a label. Okay, so let's see, I'll put in my name. So here's node 11. Actually, there is a difference between name and label. So name is stuff that came from the CSV file, and that is all from your data file. Label, on the other hand, is something that comes from Gephi. So these first three, they're used by Gephi for displaying things. And the name here is the stuff that came from the data file. So I just added myself as node 11. So I'm now here as Jarno. So if I go back and I turn on the labels, there's only one called Jarno because it's the only one that I gave a label. But I can copy data to other columns. Oh, select label, copy name. So copy data from name, copy to label. If I do that, then I get the names as labels. And if I look at overview, then everything is there. So yeah, that's the difference between data you read in and data you display. So I should have put in my name here. And my favorite color, orange. And age is like 99. It's not really my age, but close enough. And then copy data to other columns. So I'll choose the name column, copy data from name, copy to label. And then I should be right there. But I'm not linked to any of the other ones. So I go back to data laboratory and I'm node number 11. So if I go to edges, I can create a new edge. So I want to connect myself to, I don't know, Ahmed. Okay. And then it gets added. I added this undirected, so that means it has no arrow type. So it's both back and forth. So I go back to overview. You can see I'm here and I'm connected to Ahmed. And there's no errors because it's an undirected one. I go back to data laboratory. The weight is actually set to quite high. So I'll make that a bit lower, 0.4. And now my connection is a lot less. Oh, I see a question. Actually, multiple questions. Any way to rotate the edge label so that it adjusts with the edge? Oh, I'm not sure. If it was there, it would have been with edge labels. So put it there, the labels. Oh, I didn't put edge labels in there yet. Let's just put an edge label in, edges, label, preview, refresh. So there is a label. Make it a bit bigger. Yeah, that does not seem to be possible. That's kind of surprising. Turn off curved. Yeah, there might be a plugin for that. Let's see. That's colors, that's not it. Yeah, I'm not sure. That doesn't seem to be possible. I should look into that a bit more. You'd think that would be possible, but it's not. Okay, I'll get back to that. Other question, are you specifying whether a data file should be a node versus an edge, or is there something in the data that makes a specification? Yeah, that's a good question. So when I imported it, it automatically detects it. So if I open the data and I choose connections, it will already detect it here as this is an edges table. So in the import dialog that you get, it will autofill this field here. And for the connections, it detects that this is it is probably an edges table. And the way it does that is because it finds two numbers and a weight. So from that, it kind of gathers that this is supposed to be a connection, so an edge table. And the same for the other one, label. We have one ID and then a bunch of text, but since we only have one ID, it's kind of assuming that this is a nodes table. Yep. Okay, so if we go back to overview, we make like a little layout thingy. We can also make it display other things than label. So by default, it uses label, and when I put that in the data field, I just copy it over. But you could specify what you want to show. So I could have just taken like favorite color, and then it shows you the favorite color. The default is label. And the nice thing about label is that you can then alter it independent of your data. So it kind of depends on what you want to do. And also it's required for the preview. So if I change this to favorite color, and I go to the preview and I turn on show labels, preview will always take the label column. So now, even though I had selected favorite color here, if I go to the preview, it always just takes the labels. So if you want to change the labels, you need to actually change that in the nodes table here. Any questions about that? The data laboratory or anything in general? Okay. So then we can go to the plugins. So we needed a plugin to read the Web of Science data. So I'll just close this project again. Close projects, do not save. And then tools, plugins. If I go to install plugins, I will have to convert Excel and CSV files to networks. So that's a plugin that we need for the Web of Science data. And it takes Excel and it takes CSV files. So yeah, you need to have that one enabled. Otherwise, you won't be able to import the data. Because if you go to File, Import, you will only see this one if you had installed that plugin. Okay, so then is there a bit about getting the data? Oops, there we go. So this is the Web of Science. I realize that not everybody might have been able to access this because it's only available to institutions. So if you want to see this one, you have to be either connected to the VPN for your institution or be on campus to be able to get to the screen. Yeah, so I should have said that. Here you can then search for a topic. I think I took symplectic geometry, which is an area of math that my wife specialized in. So that's why I know it. And the misspell, I was supposed to get more hits than that. Anyway, if I go to export, I can export as, hey, where did it go? Supposed to be able to export to tab delimited file. Oh, that's weird. This was different last week. Okay, let's just go to the beginning. So symplectic geometry, search, export. Okay, I'm not sure why it changed, but other file formats, it still lets me choose tab delimited. There's just various options here. It doesn't really matter too much which ones you pick. The UTF-8 one is nice because it does the accents correctly. So I'll just choose that one. This one's limited to 500. Before it was limited to 1,000. Huh. So yeah, this has like an export limit. So you need to trim it down a bit. One way of doing that is selecting the publication years. So if I select the last 3 years, I get 429. So now if I go to export other file formats, tab delimited, and all records, export. And then again, a file like this, which is a tab separated file with all these cryptic codes. And then AU, it stands for offer, and that's what we're going to use. But if you want to have more data, we can change this. We go back. Where did it go? So the interface is different from what it was before. I'm not sure why that is. Symplectic geometry. So I exported 2021, 2020, 2019. But if I also want more, I can take 2018, 2017, 2016, and then refine. Get 440 results, export, and all records on page, export. And I have another text file. This isn't right though. It's only exporting 10 instead of all of them. That is weird. Oh wait, I know what I'm doing wrong. Okay. So symplectic geometry, take those years, refine, export. I chose all records on page, but that's only the 10. I should have chosen records 1 through 429. So that's all of them. Export. So now it's saving 429 records. That makes more sense. Okay. And then I go back. And then I do the same for 2018, 2017, 2016, refine, export these records, export. Okay, so if I open those two, that one and that one, so we now have the last two files that I downloaded. And these are 446 lines and 431 lines. So the tricky part is to combine these things. You'll notice that there's like a header for both of them. And if you want to combine them. So these are the 3 years these are the years 2018, 2017, 2016. And you want to combine them with the others. So we can delete this one, the headers, then copy everything. So select everything, copy. And the other one, we can go to the end of the file and paste it there. Oops, it was not paste. Paste it there. So now we have 875 lines. So I'll save that. So now our file savedrex7.txt, it contains 875 entries for the past 6 years of articles about symplectic geometry. Yeah, I hope you were able to follow along. I was a bit confused that the website changed on me. If you looked at the slides, the screenshot was actually different from what it was. But yeah, the trick is to, you have to stick within that limit. So you have to, in this case, stay under the 500. And you export that to text files. And then when you have a text file, and you have multiple text files, you need to make sure that you remove this header. And the rest of the content you paste after the original file. So saverex7, it has like the header, and then all the other stuff is the actual data without the second header from the second file. So now we have some data, and we can go back to Gephi, and we go to File, Import. We use to convert Excel and CSV files to network. Then we select the file. So it's in Downloads. And then savedrex7. You can see I've done this quite a while. And they are separated by tabs in this case. And I want offer and the offer. So it connects offers to other offers. And for the question earlier about keywords, you would have the different fields. I'm not entirely sure which one that would be because they use these cryptic abbreviations. And then you can have like what's called subfields. So if we go back to the offer field, so here we have this whole thing here. So that's offer field. But if you look closely, these are actually multiple offers that are separated by the semicolon. So the offer field has like multiple offers in it that are separated by a semicolon. So that's why we choose semicolon here. Next. This is not a dynamic network. So dynamic network, we won't really talk about it, but you can put in like a time dependence in your graph. So you can make an animation of how a network evolves over time. But I don't have any data sets for that, so we don't, we'll skip that. So next, then it asks about the links to create. So we want to create links between the offer agents and the other offers. And we want to remove self loops because often an offer, if it's on a paper, it links to the same paper, then you get these self loops and they just mess up the diagram. So you don't want that. So you only have create links. What does ticking the second line do? Yeah, so if you have multiple links between two offers, it will just add another edge. And if you click this link, it will not make those double edges. In this case, it's not relevant for us because there's not. But it kind of depends on your data set that you're using. So in this case, you can just leave it off. Sure. And then when we're ready to import, you get like a little summary for what we're about to do, and then finish. And you can see here I imported 1407 nodes and 1500 edges. Okay. And since I'm still in a data laboratory, I get all the data here. So these are all offers that it found. And these are all offers that are connected to other offers. So if we go to the overview, we get this really big data. And you can see if I mouse over and it hits like a note, it will tell you what it's connected to. Any questions about the importing of data before I go to the next part? Okay, so then we have this like randomly placed nodes. It's similar to what we got when we loaded the high school data. So we're going to do the force atlas again. And it's slowly going to spread it out. And how fast this is depends kind of on your computer. And I must admit, it's kind of mesmerizing to see it do this. Yeah, you've got like a whole string here that looks like it's together. So I'm going to help it a bit. I'm going to configure the dragging like we did in the previous. It's a bit big. Then I'll take you, put it over there. So I helped them along a bit. And then set it back to 1. Okay, that's probably okay. And then I switch to first amount rankled again. And now it's trying to make like equal distance between the nodes, but still keep the connections at the same spot. So you can see in the middle, there's all these single offers that actually don't connect to anything at all. And here, there are these groups of a lot of offers that work together. Let's see, there's another one, big cluster there. Okay, I think it's done, so we'll press stop. And now we can do the modularity filter again that we did before. So we go to statistics, modularity, there it is, run. Okay. So I get like your modularity class. And then if I go to color, ranking, modularity class. Oh, I accidentally chose size. That's not what I meant. So I'll put that back to unique. Color is what I want. Partitioning, modularity class. And it shows you the 1, 2, 3, 4, 5, 6, 7, 8 biggest groups. And the rest it just keeps gray, as you can see, because they don't contribute enough. But if you want, you can color them yourself. But here we just color them. So we got this big cluster here. It's not a big cluster there. It's not a big cluster there. So let's also make the size and do that by degree. Like that. And I'll just make the edges bigger again, so you can see something. Let's see, let's change it. I guess I made the notes a bit too big. So I'll just change the maximum size to 40, that to 10. Yeah, like that. So now you can actually see something. It's still a bit cramped, so there's another thing we can do. Layout, there is expansion, and that's different from the other ones because if you press run, it immediately stops. So it literally just scales, in this case, by 20%. So from the middle, it expands by 20%. And if you run it again, it just spreads out a bit more again. So that lets you keep the same the same layout, but just push everything a bit further away from each other so you can actually see the individual nodes still. And we don't have as much overlap as we had before.
All right.
And then we can filter by topology, degree range. And if we just put this slider a bit up, so say 2, and we filter, then we filter out all the single offers, and then we have like a more, a better overview. So yeah, this lets you like analyze the networks. You can put on the labels too, so you can see the offers. So we have like a big group here of looks like mainly Chinese names that work together. So any questions about loading data from like an online data source, like Web of Science, and then analyzing it a bit? Okay, so the last question is, did anybody try this with their own data? Like, were you able to load it and make some sort of sense of it? Not sure if anybody got that far. If not, there is a bunch of data sets on the Gephi site that you can also play with. So there's quite a few. Let's see, what is a nice one? Let's see, what do we have? Oh, right, Les Miserables. So we can download that one. And that is one GML file. So extract, oops, it's too big. Extract. I'll close this one. And I'll open that one. So that is something I just downloaded. That one. So these should be the actors for Les Miserables. So you can force Atlas and then expand it a bit. I've never actually seen this one, but this is like an example of data that you can download from the internet. And you can see how all the actors in the story relate to each other. And it's also really easy to see who like the main characters are, especially if you take the size and you rank by degree. You get these big ones that are clearly the main characters in this story. Make it a bit bigger. And if I color that, like that. Let's see, I want to make it kind of a light color, like that. And the edges, I'll make dark. So yeah, you can clearly see that Faljean, or I'm not sure how you pronounce it, is one of the main characters, and there's like a big relationship with Cosette. I don't know if anybody knows this show. I must admit I've never seen it before. So yeah, that is kind of the end of what I had to present. I was hoping somebody would have pictures as well, but we're coming up to the full hour anyway, so it's a pretty good time to end. So are there any other questions about Gephi in general or data acquisition or anything like that?
Definitely don't be shy. You can raise your hand and talk to us too.
Seeing the whole press has been very helpful. Thank you. Yeah, you're welcome. Okay, so it looks like we have no questions. Yeah, I'll send the recording out and Jarno will put it on YouTube. And I think I haven't actually sent the slides, but everybody probably downloaded them from the link in the beginning, so that's fine.
Yeah.
But yeah, oh, sorry.
I was just going to say I can also link them on the DH site website as a sort of backup for those who maybe lost their download.
Yeah.
Sorry, and go ahead.
No, I said yeah. That's a very good idea.
Okay, perfect. And we should also mention that we're doing a whole other workshop, another two-part workshop, November 1st and 8th, both Mondays, same time, 10:30 to 11:30. And that's on the topic of d3.js. Am I saying that right?
Yeah, I think you are.
I'm supposed to say the dot out loud. I'm just never sure. So that will be on interactive or dynamic data visualization. So if you're interested, the registration is open. You can go to dhsite.org and go under the workshops tab, which is nestled under events, I believe. And you can register for that workshop series as well. Yeah, and I guess that's it. So thank you very much, everyone, for joining us, and thank you, Jarno, for leading us through all of this. This is a really informative session, and I have a feeling that we'll see a lot of really cool projects. Share your projects with us when you're done. Please
Yes.
tweet us or send them in via email, and we'll find ways to share them online for you. But we're really excited to see what you do with all of this new knowledge.
And feel free to, of course, always contact me. If you get the Eventbrite emails, you can just reply to them and they'll go to me. So don't hesitate to ask any questions.
Perfect. All right. Thank you very much, everyone. Have a great week. And
bye-bye.
upcoming holiday weekend.
Yes, don't forget that.